here, just talking about the definition of polynomial in general. We are getting nervous. Thought you were going to skip out today. All right. So when I am talking about a polynomial, this is up at the top, that box. You're going to fill in some things here. The degree is n. N is just a non-negative integer. In a polynomial, every power is a whole number. So 0, 1, 2, 3, 4. You can't have a negative power. You can't have a radical in the power if you're talking about a polynomial. So the actual definition of a polynomial looks like this. We'll see that pop up here and there. Just wanted to show it to you today so you can get past the being scared when you see a bunch of these different variables. All that's saying is we're adding together a bunch of different powers of x. The n minus 1, so forth, that's just your power. The a's are just representing coefficients on each term. Okay.
Yeah.
You need to pass.
That's just fine. It doesn't matter. Thank you.
All right. In this, when I'm talking about the degree, that is just the highest power. So in this scenario up here, that would have been the n. Next definition, we have the leading coefficient. That is just the coefficient of the term with the highest power. So for us, it would have been that a sub n, that coefficient on the term with the x to the n power. What is a constant? A constant is just the term without a variable. So that would be like the a sub 0 up there. It's the thing without an x in it. So first we're just going to look at a few polynomials and see if we can pick out these things, the degree, leading coefficient, and constant in each. So this first one, 5x minus 1. What is the degree, the highest power? You have an x, that's like an x to the first, so it's a degree of 1. The leading coefficient, that's the coefficient on the term with the highest power. So here's the highest power, so the coefficient there is 5. What is my constant term? Negative 1. Second one. What is the degree? 4. Leading coefficient? Right, you're looking at that x to the fourth term, so the leading coefficient is just a 1. What is the constant? 0. We don't have a term without a variable, so it's just a 0. All right, last one. What would be the degree? 3. It's not necessarily the first one. You have to look at every term and just pick out your highest power. So this is the degree of 3. The leading coefficient there is negative 1/2. You have to look at the coefficient on the term with the highest power. So it may not be in the front. That x to the third was the highest power, so you look at its coefficient. And what is my constant? 5. Are we okay with what those terms mean? If our function is just equal to 0, that's called the zero polynomial, which has no degree. Here's the reason. 0 is the same thing as 0x, which would be degree 1. But that's also equal to 0x squared, which is degree 2, or 0x cubed, which would be degree 3. If it's just a 0, you could put x to any power with it. So we can't give the degree there. But if I have something like f of x equals 3, is 3 the same thing as 3x? No. What power would I have to put on that x to make it go away? 0. Anything to the 0 power becomes a 1. So if it's just a number other than 0, that's degree 0. Degree is like saying how many variables are there. If you have a 3, there are 0 x's with that. Okay. The rest of the day today we are looking at a specific type of polynomial. We are looking at a quadratic. So what is a quadratic? It has an x squared in it. We've talked about those a little bit. So in general, it's going to look like f of x equals ax squared plus bx equals c. We've looked at just y equals x squared in the last chapter. That was one of our parent functions that we did transformations with. So we've seen a little bit of this already. So that's the box there in the middle of your page. Everybody get this formula written down? Okay, what's the graph look like? A parabola. Parabolas can either open up or open down, which will determine if they have a maximum or a minimum point. If you have a parabola that opens up, this point right here, is that a maximum or a minimum? Minimum. So if it opens up, it has a minimum. If it opens down, this point is a maximum. That point is also called the vertex of the parabola, that highest or lowest point. When we're graphing these, we'll also talk about the axis of symmetry. That's the vertical line that would divide this in half. A line you could fold on so it overlaps itself. So when we graph this, our techniques are going to kind of depend on what form our equation is in. The first form, standard form, is the one we already wrote down. F of x equals ax squared plus bx plus c. It could also be given in vertex form. A times x minus h squared plus k. When it's written like that, then it's really easy to do transformations to get the graph. It'll move left and right, up and down. So the vertex is actually going to be that hk value. We don't have to learn any new rules for transformations. Everything we've already learned is still true. So all the same transformation rules that we've had in the past. So let's start graphing this. If I just give it to you, f of x equals x squared plus 4x minus 4, can I do transformations to graph that? No. So let's just say we made a t-chart. When in doubt, that's what we've done in the past. If we don't know what the graph looks like, we just make a t-chart. Let's try that. What do you guys want to plug in? 0, 1, okay. If I put in 0, 0 squared is 0, plus 0 minus 4 is negative 4. If we put in a 1, 1 plus 4 minus 4 is 1. Is that enough to know what my graph looks like? No. What if I put in a 2? 2 squared is 4, plus 8, minus 4, 8. Do you think I should plug in something bigger than 2, or should I go the other direction? Probably the other direction. Let's try negative 1. So negative 1 squared is 1, minus 4 minus 4 would be negative 7. Is that enough to know what it looks like yet? No. When will I know? Yeah, when it changes direction. When I get that vertex and it starts repeating when it's already done. Okay, let's just keep trying then. Negative 2. Negative 2 squared is 4, plus negative 8 minus 4. So we get negative 8. We're still not there. So if I put in negative 3 squared is 9. Minus 12 is negative 3. Minus 4 is negative 7. Do we have it now? Yeah. The nice thing about parabolas, they are always symmetric. When you know what your vertex is, the line going through there is your axis of symmetry. I think Mrs. Keller usually made you draw that in with the dashed line, because then you knew any point that you had, you could reflect it over the line. For instance, this one was 2 away from the line, so if you went 2 the other direction, there's another point. This one was 3 away, so if you go 3 the other direction, there's another point. This is 4 away from my vertical line, so if you go 4 the other direction, there's another point. And so that just helps make our graph a little more accurate. What's the domain of this? What's the range? I didn't ask it on this one, but I could ask you, like, where is this increasing and decreasing? We were doing that on the last test. This one, does it start off increasing or decreasing? Decreasing, coming from negative infinity. Stopping, you always give me the x value, so stopping at negative 2. And then beginning at negative 2, it's increasing forever. So I could have asked those questions. I could ask you, where's the vertex here? Do you give me the order of pair for the vertex? Negative 2, negative 8. Does this parabola open up or down? It opens up. Does it have a maximum or a minimum? Minimum. If I ask you what is that minimum value, I'm just saying what is the lowest y value, so that would be negative 8. So I could ask you a lot of questions about this. Now, why might I not want to graph every single one of these by plugging in points? What's the downside here? Okay, depending on my points, I might run out of room on my graph. You know, they could get really big really fast. It takes too long. We like to rush through things, right? We don't want anything that takes too long. So what if I hadn't found my vertex? What if my vertex had been at like negative 2/3? Would that be something you would automatically think to plug in to find the vertex? No. So if my vertex isn't nice and pretty, it can be very difficult just to graph these by plugging in points. So this we just did to show you that this works, but it's not going to be our ideal method because it just takes too long. So some other options we have. We've already graphed these things by transformations. So sometimes they're written where that is going to be an option. If you do transformations, how did I make you do that on the last test? What did you have to do? Parent function. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3, 9. Negative 1, 1. Negative 2, 4. Negative 3, 9. You only had to have 3 points, but we've got a graph already. We might as well fill it up. What will that negative do? And what does the 2 do? Easy way to think about this, there's a negative 2 out in front, so let's just take out in front changes y, and it does what it says. So we're going to take our y's times negative 2. This point has a y value of 0, times negative 2 is still 0. This has a y value of 1, times negative 2 is negative 2. Here we have a y value of 4, times negative 2 would be negative 8. So negative 1, 1, move down, this one moves down. So we're just getting a skinny upside down parabola. So is this one open up or down? Down. Maximum or minimum? Maximum. What is the maximum value? 0. Where's the vertex? 0, 0. What's the domain? What is your range? Okay. Is that one all right with everybody? Why don't you guys graph C by transformations? So do your parent function, your transformations. So what will my transformation do?
Down 1, right 3.
So where does your vertex end up?
3.
3, negative 1. Is that a maximum or a minimum? What's my domain? Range? Okay. So if they're written in vertex form, they're pretty easy to graph. We can do our transformations. But that first option, A, was not in vertex form, so it wasn't quite as easy. So here's what we can do. If we have a quadratic equation in standard form, to find the vertex, you are going to use this formula, x equals the opposite of b over 2a, to get the x value of your vertex. And then you will plug that value into the equation to get your y. The axis of symmetry is the vertical line going through the vertex, so it is just x equals opposite of b over 2a. Since it's a line, you have to have the x equal, so it's just x equals the x value of your vertex. you need a minimum of 3 points. So how would you get your y-intercept? It's an easy point to find. It's where you hit the y-axis. So what's the value of x?
0.
So we'll plug in a 0 for our x to get the y-intercept. All right, so we're going to graph a few of these, and then that'll be our stopping point for today.
Sorry, what's the one before that? The axis symmetry has equation.
X equals opposite of 2a. Same as the x values of vertex.
Oh, okay.
So, we are going to find all of these things and graph it. I don't want to just plug in points. We could, but it would be time consuming. So we're going to try using these other things we know. So to get the x value for your vertex, you do the opposite of b over 2a. What's my b value?
2x.
Yep, and you just take the coefficients. So it's a negative 2 over 2 times, what's a? 1. So 1x squared. So you get negative 2 divided by 2, which is negative 1. That's the x value. So to get y, you have to plug that back in. So we get 1 minus 2 minus 5, which is negative 6. So the vertex is at the point negative 1, negative 6. The axis of symmetry, I will take off if you don't write it as a line. So it's x equals the x value of the vertex, which is negative 1. How do you find the y-intercept?
Times it by 0.
You plug in a 0 for all of your x's in the original equation. So we get 0 plus 0 minus 5, which is negative 5. Okay. I want to stop and graph this stuff. So my vertex was at negative 1, negative 6. Axis of symmetry, we just draw that as a dashed line going through the vertex. My y-intercept was negative 5. Now, I've always told you you have to have a minimum of 3 points. I only have 2. How do I get a third? Yeah, reflect that y-intercept across your axis of symmetry. So there you've got your third point. So we have our graph. What is the domain? Yeah, every time. Negative infinity, positive infinity. What's my range?
Negative 6 to positive.
Any questions on that one?
Will the domain always be negative 1?
Yes, every time. We're going to do another one together, and then I'll have you guys try the third one. All right, so first step, if I want to graph this, it's not written in vertex form, so I can't just do my transformations. So instead, we do the formulas. So your vertex, we have to do x equals opposite of b over 2a. So my b is 7, so opposite of 7 over 2 times, oh, not 7, opposite of negative 6, isn't it? So that would be a positive 6. So that gives me a 1. Then we plug that back in to get our y. And that gives us 4. So the vertex, make sure you write it as an ordered pair, is 1, 4. Axis of symmetry would be what? And we have to give it as an equation, so it would be x equals 1. It's a vertical line, so always x equals. How do we get the y-intercept?
Plug in 0.
If we put in 0 for all of our x's, we get
7.
Put my point at 1, 4. Axis of symmetry is the vertical line going through that. Y-intercept is 7. And then to get our third point, we reflect the y-intercept. Our graph looks like that. Domain. Range.
4 to positive 2.
You guys do C. So you plugged in opposite B over 2A. Oops. It would help if I could write down my problems correctly, wouldn't it? So you get -8 over -4, which is 2. Plug that in, so h of 2. So 2 squared is 4, times -2 is -8. 8 times 2 is 16, minus 3, and you get 5. So the vertex is at the point 2, 5. So that means the axis of symmetry is the vertical line going through that, so it would be x equals 2. Y-intercept, if you plug in 0 for all of your x's, you get 3. So you get your third point, you reflect that over the axis of symmetry. And hopefully your graph is a little bit better than mine. So what's my domain? Range? Yep. Okay. This is where I want to stop. There is a math Excel